Mm.
Alltså jag är som en fluga eller insekt. Jag vill titta upp i ljuset, inte in i kameran.
Du kommer gå mot lampan sen.
Drar mot ljuset.
Mm.
Nu börjar vi få panik. Welcome to the webinar, The Silent Plea of Fish, Animal Welfare in a Consumerist World. This webinar is live streamed, but it's also recorded so that you can watch it later if you want. What we offer here today is a thought-provoking webinar on fish welfare with a particular focus on humane killing of fish, both in aquaculture and in fisheries. And this webinar is organized by Animal Welfare Sweden, or Djurskyddet Sverige, and the Swedish University of Agricultural Science. My name is Karin Gabrielsson Morton, and with us here today is Dr. Albin Gräns, a researcher at the Swedish University of Agricultural Sciences. And you are considered to be one of the world's leading experts on fish welfare, and with a unique competence when it comes to stunning and slaughtering of fish. And Albin will give a presentation that includes his latest research on animal welfare problems during slaughter of fish in aquaculture, as well as when wild fish are caught for consumption. Albin, please tell us how the welfare of fish can and needs to be improved. Thank you.
Okay, thank you, Karin, and thank you, Djurskyddet Sverige, for organizing this webinar. So I will focus on some of the research that me and my research group have conducted over the past 15 years or so. And the focus is on the final time during the life of the fish, so during the slaughter or killing. And we all know that it's an enormous amount of animals that are being killed annually by humans. This is a figure that I found from Eurogroup of Animals, and it struck me that I tried to conduct or make a similar figure myself, and it didn't look like this. So if we changed the bars for the fish within the range that they write here, we actually see that even with the lowest number, it goes way above, outside the drawing. And if we take the long one, it's just almost covering the whole screen. And this really shows, highlights the enormous amount of animals that we're talking about that are annually. It's almost impossible to understand how many animals this is. And the majority of these animals are killed in wild fisheries. So recently we conducted a study where we look at the welfare of trawled fish. Particularly we looked at Atlantic herring, which is both used for meal, fish meal and fish oil for feed, but also for human consumption, especially in the Nordic countries. So the focus of this study was to focus on how to implement killing methods on the vessels. What we saw that you catch enormous amount of herring in every catch. So in this example, we caught approximately 800 tons, and it was trawled for 2 to 5 hours, depending on what holds. And just to highlight how many animals this is in one catch, 2 to 6 million herring, which is in terms of individuals, as many as the whole aquaculture production in Sweden, but for a year in aquaculture in one hole with one trawl in the large-scale fisheries. What we saw was that all these herring coming up, almost all scales were gone. So more than 90% of all the scales were gone. We also tried to draw blood samples to get stress hormone levels, and what we saw was that it was impossible to get the hemolymph, or because all the blood cells are ruptured within the fish. Also, it was evident that these fish, our job of actually looking for implementation of killing method was a bit off the target, because this herring coming up to the boat was already dead. 90% of the caught herring were already dead. So actually killing fish on these large-scale vessels, this will be a challenge. And maybe it's not the killing method per se, but actually the fishing method that we need to focus on primarily. We know also that aquaculture suffers from high mortalities. Last year was a sad record-breaking year in Norwegian salmon aquaculture, where this article reported 105 million dead salmon from the farms. This is due to diseases and lice, and maybe especially the treatment for lice. But also important is that within aquaculture in the world, we have 37 billion estimated animals that survive and need to be slaughtered in a way. So this is what we focus most of the research on, and it's how to slaughter them in a good way. And here we come into this humane killing or humane slaughter. So what do we mean with humane slaughter? Well, the animal should not experience any fear, anxiety, pain, suffering, or distress during the slaughter. And what we want to see is that we have a stunning effect that's immediate. And that's what you see in this red graph, that it goes immediately down to green from conscious to unconscious, and then it remains so until the animal is dead. With ectothermic fish, what we often see is that the stunning effect is transient, so the animal is recovering consciousness before dying, and this is of course not what we want. We also see some examples where the effect is so short that the animal is actually already back at the time of killing, which is usually a bleeding or gill cut. There's also some stunning methods out there that have a not immediate effect, but it takes a time for the effect to hit in, and this might be either the killing or the stunning. So it takes a period before the animal goes unconscious, and during this time it's risk that animals is suffering. Now the question is how to assess whether or not a method is humane or not. And we're looking at the literature. We can see there's a lot of different methods being used. We have reactions to needle punctures, stress hormones like cortisol, heart rate, rigor mortis, which is stiffening when dying, and all these other things. I'm going to show a little movie to highlight what I think is important here. So this was lifted a bit of a zombie fish on YouTube, and it's a lady that's descaling a carcass of a bowfin, and it's been decapitated for 1 hour when this happens, and people were reacting to how this carcass is almost trying to bite the hand when trying to descale it. But from a welfare perspective, what's important here is when the camera pans out and you see the sink, because here 1 hour after decapitation you can see this head is still active and watching what happens to the carcass. And for me it really highlights the importance of, if we're going to assess a slaughter method on an ectotherm like fish that can live for so long even with the head detached from the body, we need to focus on what is the head perceiving. And to do that we use EEG monitoring, and this is we do it in fish, but it's also done in other animals. So what we did, we further developed a technique for doing these EEG emission monitoring. When possible, we use this non-invasive method where we use plate electrodes that are sucked onto the head, similar to what you would do in a human. And this has been successfully used for a range of different species. Now, this is a pretty technical and complicated method. So you might ask, why not just look at visual indicators or operational indicators like loss of equilibrium, ventilation responses, things that you can easily see which are by just looking at animals. And what we see is, the problem is that a lot of these visual indicators, they are lost way before the brain stops functioning. And if you, depending on what variable indicator you choose to look at, you might be missing by several minutes when the animal is really going unconscious. And again, this is something that we've seen in all the species that we investigated so far, and it's not just, this was an example from rainbow trout, but we also seen it in a range of different species. So our conclusion from this is that yes, operational indicator or visual indicators, they are very important and they should be used as much as possible, but you can use them only to, when they're present, you can see that this is a failed stun. You cannot use them to verify that you have a functional stun, because then you need to go into the investigations of brain activity through EEG measurements. So how should we do these assessments? Well, if we look at EFSA, they recommend a study approach. It's a two-step process, and we start with the first one. So you should start with the laboratory study, and this should be done under controlled conditions. And there you should find like what stunning parameters are successful in the lab. And for doing this, again, based on what I was just showing, EEG measurements are the golden standard. So if you remember from this definitions of humane slaughter, it should be immediate and it should last until death. The immediateness can be assessed in EEG by the presence of a tonic-clonic seizure, often called, also referred to as a grand mal seizure. And this is a high activity in the brain where all their synapses are emptying out, and during this stage the animal is believed to be incapable of perceiving its environment. And this should be very intensive and it should last for at least some time. Then to assess that the effect remains until death, we look at something called visual evoked responses. So this is something that we trigger, and that's important in fish that we get rid of all the noise, because as you might see in a fish, that the brain, the gills, the heart, everything is basically in the same area of the fish. So there's a lot of readings in the EEG signal that are actually not EEG but biased from the surrounding. But by having these time-triggered responses, we can filter all that out and just focus on the effect by our trigger. In this example, and what we usually use is a light stimulus. And there what we can see on the left side here is the reading from a conscious fish, where you can see a clear mark triggered by this light, while when the animal goes unconscious, it's not reacting to the light, which shows that the brain is malfunctioning. So what method should we be focusing on? What should we assess and how to move forward with this? Well, from the pioneer work from the Bristol group, they did this work in rainbow trout. Already in 1991, they showed that live chilling and asphyxiation that did not fulfill the standards of humane slaughter. In 1995, they ruled out carbon dioxide stunning, and then they lifted electrical stunning as percussive stunning as possible alternatives that could live up to the standards of a humane slaughter. And since then, we have seen a large movement towards electrical stunning and percussive stunning. And just this year, ACS, the Aquaculture Stewardship Council, they implemented that it's mandatory now to electrically stun European sea bass and Atlantic or gill-head sea bream prior to slaughter. I'm always a bit concerned when I see writings like this, where it just says that electrical stunning should be used, because we also know that electrical stunning is very complex. You can do it in air, you can do it in water. You can use a range of different currents, voltage, frequencies, waveforms. You can use AC, DC or combinations of these. You can play around with exposure times. Different species are very different how resilient they are to electricity. Also temperature effects and salinity of the water, etc. So something general like this use electricity, it needs to be come with the specifics of this is what to use for this species. And when looking at sea bream and sea bass, we had opportunity to test one of these machines in a lab. Here we looked at how long the effect lasted of electrical stunning. And these parameters used are we expected quite high effects of this because it's low frequency and quite high currents. And even so, we saw recoveries within 2 seconds for sea bream and within, or 2 to 53 seconds for sea bream and 5 to 85 seconds for sea bass. So both these species, the stun effect was so short that it actually gives us very little time to implement the killing method and have the killing method have effect with both these species. And again, this is not one shot in the dark. We've been working with a range of different stunners. We worked in total with 6 different companies and a range of different species. And the conclusion we draw from the sea bass and sea bream study is pretty much what we keep coming up to with different methods. For not one of single of these have we found any parameters that we felt was good enough to move forward and implement in a farm situation. So what should we focus on then? Well, we know that bleeding, we saw from the bowfin, that's not a good way for to kill an ectotherm without prior stunning. Electricity, we have some doubts, and it might be some species where it's not usable for the most resilient ones. Another method lifted is this ikijimi or spiking, which is developed primarily for protecting the quality. But also here we see that this is not an instantaneous method, especially if the animals are quite big. So the ratio between the size of the brain and the spike is very, that difference is large. It causes the hemorrhage that will kill the fish, but it takes often several minutes for it to happen. And this is also what was reported in Atlantic salmon by the Bristol group already in 2000. So what we're left with is percussive stunning. But here we see that the success rate is highly dependent on the force and the accuracy of the blow. And it's been a lot of discussions and questioning, like how scalable is this to commercial size? And that brings us back to the recommendations by EFSA. So we had the laboratory study, and then when we find parameters that works in the lab and successfully stuns the animal the right amount of time, then we should move out to the commercial site and do commercial studies. And here we should do this evaluation. How feasible is this in a commercial scale? And when looking in the fish literature, here we're pretty much stuck. We're waiting for a good example. We're waiting for a study or a method that's been shown to work in the lab successfully and then moved out to commercial studies and implemented there. So what's the risk of working like this and skipping one of these stages? Well, I have a couple of examples of that, and one is this. In Germany there's a rule that you need to use percussive stunning and whole body electrical stunning in water when stunning in Germany. This is used for common carp, and some colleagues in Germany went out to 17 different commercial fish farms and investigated. So how well is this working out in reality? And it was quite striking, the results, where the farms that were using percussive stun, they had up to 60% failures, electrical stunning up to 50%, and the combination of percussive and electrical, which you might expect be the highest success rate, but actually the farm with the most fails, 66%. Similar situation, recently was published for Atlantic salmon, where Mattilsynet in Norway went out and see how well it was working, and they found numerous non-compliance with when identifying concerning fish stunning, with 60% of the slaughterhouses were found to be non-compliant in the area of stunning effectiveness. Now, this might sound super negative, and there's a lot of backsides to it, but I also want to highlight that don't let perfect be the enemy of good, because even for the German system, if they moved from asphyxiation to 50-60% success rate with the electricity, it's still a 50-60% improvement compared to what they did before. And for the Norwegian system, yes, maybe it's not functioning as it should in all slaughterhouses, but they moved away from carbon dioxide stunning, which we know is 100% unsuccessful. So we cannot call it a humane slaughter, but it is definitely an improvement from what they had before, and it's not the goal. And one reason why this has not been done in a larger scale is the problematic of doing this kind of investigations out on commercial sites and also out on fishing boats if we want to move forward to wild fisheries. And here we have this project that we call the Fishbox Group. And the aim of this project is to develop a system that is portable, inexpensive, user-friendly, and robust enough to withstand the harsh environments where fish are normally caught and slaughtered, which is the slaughterhouses and the fishing vessels. So here we focus on these recovery, on these visually evoked responses, and the reason for this is that this is not a relative indicator. So what we can do is that we can take a fish coming out from a stunner, wherever stunner a company or a slaughterhouse is using, and then put it into the box and see if the brain is still functional or not. And in this, we also try to get rid of all the expensive equipment and try to streamline it, so it's only focusing on what we actually need. And then we will have something like a light system that shows this is at 10 minutes. In this example, we see 5 green dots followed by 5 red dots. So that would mean 5 minutes of unconsciousness, and then it recovered within the last 5 minutes. So for this fish, you would have to do something to prevent that recovery after 5 minutes. We also try to link welfare and product quality in this work. And this is because, and we have different measures of investigating that. And this is because we see this clear relationship between how the animal was handled and the product quality that comes afterwards. And I believe this gives us a bit of a common language sometimes with the fishermen and fish farmers. Because if we look at, this is preliminary data where we looked at successful stunts compared to failed stunts. So stunts that were considered humane versus inhumane. And only during those last minutes of life we can see an significant effect of how much water is lost in the fillet. And this is of course mass, so this is what the farmers and the fishermen are selling. So this would be direct economic effects. So how should we move forward? What's the roadmap for progress here? Well, one, like I mentioned, we should not let perfect stand in the way. There are methods that we know compromise welfare, and we should discontinue these. We should shift from something, from a procedure focus, like this is a method, but actually on the welfare outcome. So this is the effect that we want a method to have. We should promote evidence based policies through research, and that's where we come in, and we need help. There need to be a lot of researchers doing this work. And we also should not be staring at the methods that we already know, but I think that there's a lot of technological innovations that could help to move the field forward. And I would like to thank you for your attention, and I will also highlight there's a lot of companies and researchers and developers involved in this, and this is really the key for moving this field forward, that we all work together, because researchers, farmers, and stunner developers neither of us can by ourselves do this, but we need to work together to move forward.
Okay, wow, thank you for that presentation. There's a lot of information packed in there. Also, thank you for your important research. So, with such an amount of facts and information, what would you say is the most important take-home message here?
I would say that the most important is that we're missing a lot of investigations. There's a lot of points missing, like we need to do the two-step process recommended by EFSA, and to do that we need to collaborate, everyone involved.
Collaboration.
Yes.
Collaboration is the key. Yeah. I also know you did mention a roadmap for success and to move this forward. And I know you have collaborated with Djurskyddet Sverige, Animal Welfare Sweden, to produce a list or like a couple of points on how to move forward in politics and on policies. What's the most important to focus on?
Well, there I think focusing on the effect of the animal is maybe the most important. So not just getting caught in one method, but actually how is the animal perceiving it? That's what's important. Because what we see in the past is that if you make the investments to a new method or machine, you're often quite resistant of actually having it tested in that commercial scale study. And that's something we want to get away with. We want to make improvements in all different stages.
So moving away from the technology and the technical specificities to like what happens to the animals.
Yeah, and there we're trying to develop another kind of roadmap for what to ask for. So how should that be we could use these operational visual indicators to check how things are functioning. So
your research and other researchers that look into what actually happens to the animals in cooperation with the companies producing the technology is key.
I think that's the key.
Yeah. Okay. So we talked a lot about a good death, how we can move forward to ensure that all fish get a good death. But you also mentioned a lot of other welfare problems that needs to be addressed both when fishing for wild fish and in aquaculture. Do you have any advice for the certification organizations? That would their job is to help consumers in the industry to move forward. What advice would you give to them?
Well, when it comes to the death part, I think this roadmap that we're trying to develop. So what to ask for, like what should they show evidence of in the systems they use. But when we figure that one out, we also need to minimize the stress from handling. We need to minimize air exposures. There's all these different things. And then when it comes to wild fishery, like I said, that is a challenge. And also, if we actually have a milder way of catching the animals, we will have to implement a killing method when coming up. So it's controlled how the animals are killed up on the vessels. And that is that will be a challenge.
Well, thank you so much for being with us here today. And this is so important. It's so many. How many animals are we talking about again? How many fish?
Almost 3,000 billion.
Millions of fish around the world. Yeah,
and it's insane.
It's insane, and you're saying there has been improvements, but there's still an enormous amount to do to ensure that they have a good life and a good death.
Yeah, but we also see a lot of movements towards it. We see interest from the big aquaculture producers in Southeast Asia, and we see the big fishing trawlers, vessels are now actually talking about fish welfare and improvements. There are challenges, but that people are actually talking about it and looking for solutions.
And you've been out on vessels to
Yes.
study what they do,
Yeah.
and would you say that they are interested?
Yes, they're interested, but also they see the challenge of, because it's always income versus welfare.
And I also understand it's a big challenge for you as a researcher because it's hard to plan. You told me before that you had to be on standby to get on a fishing vessel because you didn't know when you were going to get on it and how long it would take to get there.
No, it's difficult doing this kind of research because you need access to vessels and you can't really get on or off them during the trip. So you might be out for a week, you might out be 2 or 3 weeks, and then they don't often know exactly when going out. So like for that example, we had the rental car packed with equipment standing for a month, and then we got a call tomorrow, come to Smögen or Skagen, and then we can leave.
And that is what needs to be done to move forward on this.
But that logistics of that is difficult. And combining it with family life is a bit of a challenge.
Yes. Well, thank you so much for being with us here today and for your presentation on the welfare of fish. And we absolutely need to work together to do something about this. There's a lot of things that can and will be done. And thank you also for everybody following the live stream or watching it, watching the recording. Please make sure that you let other people know about this webinar because a lot more people need to know about what happens to fish and what can be done, what must be done to improve their welfare. So thank you all. And thank you, Albin.